All right, this week we are just finishing up chapter 7. Everything that you learned today, the only difference is, instead of writing log, we are writing ln, which stands for natural log. And it comes from this, that if I had a log base e, which remember is a natural number, it's approximately equal to 2.718 to infinity with decimal places, that instead of writing all of this, they said, well, since it's the natural number, I'm going to call it the natural log x. If you want to, go ahead and pause this video so you can take some notes on it. But just like log base 10, log base 2, log base 3, if I graphed y equals e to the x, that's this graph here, then the natural log of x is my inverse function right there. So, and that is y equals natural log of x. And we graph them just the same way as we did when we were graphing logs of any other bases. All right, so pause if you want to take notes on this. Really the most important thing is right here, and then this information and what they look like. So, just like logs, we can use the properties of logs for natural logs. So these aren't any different than properties of logs like we did 2 weeks ago. So if I were to rewrite this, I'm going to do a couple and then I'm going to pause and let you do a couple, that I know that this is the expanded form. So this 2 in front of natural log must equal the natural log of 15 squared minus natural log of 75. That's the power property. And then again, the subtraction represents division. And so my single term would be this, 15 squared divided by 75. But those are both numbers, so I can simplify those. So if you can, simplify, do. So 15 squared, all of that divided by 75 is 3. So this simplifies to just be the natural log of 3. All right. I'm going to do B down here because I want to do one with X, and then I'm going to let you practice C and D, so get ready to pause your videos if you need to, so that you guys can practice a little bit and then come back and join me and I'll go through them with you. So the 3 and the 2 here, that's both the power property. These are both exponents here. You have to be really careful here. So the first one's a little more straightforward, natural log of x cubed. But this whole thing is being multiplied by 2. So here's what we have. We have natural log of 2x, and all of that is squared. So be really careful when you are squaring that. It's not going to be just 2x squared, because this is really 2x times 2x, which is 4x squared. So I'm kind of drawing this one out a little bit just to make my point. But we have x cubed minus natural log of 4x squared. And again, we have subtraction. That represents division. So I'm going to have natural log of x cubed all over 4x squared. And honestly, at this point, I wouldn't mind if you kept it like that. But if you check your answer in the back of the book, they might have gone on to simplify. So I have 3 x's up here and 2 down here, which would leave me just 1 x in my numerator. So both of these are equivalent to each other, and either answer I would take. All right, I'm going to let you guys go ahead, pause. 1, so you could take notes over here, and 2, so you could try these couple over here. All right, So coming back, I hope that you really did try these. That's where the learning takes place, not just watching me. So natural log of 7 times or plus the natural log of 5 squared. Well, we know that's just 25. So we could write it like this. And now this denotes multiplication because of the addition sign. So it's going to be natural log of 7 times 25. Again, that can be simplified, so I should simplify it. 7 times 25 is 175. So all of this simplifies to be natural log of 175. Again, not really any different than what we've done in the past with logs. We're just now writing ln. So I'm going to go through this one a little more quickly. This is going to be natural log of x cubed plus the natural log of y squared plus natural log of 5. I didn't do anything with that. The addition just represents multiplication. It doesn't matter which order I do it in. So you should get for your final answer here 5x cubed y squared. All right. So there's the work on that if you need to pause and look at that more. We're going to go on to solving logs, just like we did when it was log base 10 is what we've done so far. We're going to be solving with natural log, which is log base e. So whenever you are solving, you need to get the log in one spot before you can do any solving. And you can see here, I only have natural log written once. So I'm ready to undo at this point. I'm going to do the inverse of log, which in this case, I'm going to exponentiate with the natural number e. So e to the power of all of this and e to the power of 4. Now over here, these undo each other, leaving me with x minus 3 squared equals e to the 4th. We need to get x by itself. So what am I going to do? I want to solve for x. So I'm not going to multiply this out. X is already in one spot, so I'm going to undo. I'm going to take the square root of both sides, which leaves me with x minus 3. Now, what do you get on that side? If I take the square root of e to the 4th, I'm going to get plus or minus e squared. I hope that makes sense. Now, last but not least, to solve for x, I'm going to add 3 to both sides. So I get 3 plus or minus e squared. Your book for checking answers has the decimals. And so be really careful if it says you're going to round to the hundredths or the thousandths. But to do this, this is really x equals 3 plus e squared and x equals 3 minus e squared. I would prefer, when you get to pre-calc, that you leave your answers in exact form, but this book does it differently. So I'm going to have 3 plus, now notice right above this natural log, there's a little e to the x. So you're going to use your second natural log and then put a 2 up there. So 3 plus e squared is about 10.39. And then if I try the 3 minus e squared, I get negative 4.389. So, or approximately negative 4.39. All right. I don't have you doing practice problems or warm up in this lesson. You can expect with the video for task 2, you will do some of that. So again, I am not ready to solve b. I see natural log in two places, and so that means I need to combine them using my properties of logs. So I notice that it's addition, which according to the product property means multiplication. So I'm going to be multiplying the 2x and the 3 together, giving me natural log of 6x equals 2. Now that it's in log is in one spot, now I can undo it with my e to the power of on both sides. Now these undo each other, leaving me with 6x equals e squared. Now I can solve for x by dividing both sides by 6. Again, this is the exact answer. Your approximate answer is going to be that second natural log, e squared, and then I'm going to divide by 6. So notice I want to make sure that divide by 6 isn't in my superscript, and I get about 1.23. All right, that's it. I hope you don't find this too hard. The E is a little weird, but other than that, it's all the same processes we've been doing so far.